Welcome to the New Stuff training for feature 13433, SR-IOV support for AHV, and feature 13073, data path offload support for AHV. In a Nutanix AHV environment, all packet processing is done in software. While this provides a lot of flexibility, it can reduce performance and lead to higher CPU utilization. Today, AHV offers VirtIO network devices to virtual machines. All major Linux distributions ship with VirtIO net drivers. Microsoft-based VMs, on the other hand, do not have a native VirtIO driver. That is supplied by Nutanix. Whenever a virtual machine's NIC transmits or receives data, CPU cycles are consumed in the AHV host kernel. With SR-IOV for AHV, we can gain significant performance improvements, bypassing the hypervisor for all network processing while transmitting and receiving packets directly on the physical NIC. We can also map multiple VMs directly to the same physical NIC, optimizing our available resources. Modern NICs can be divided into what are known as virtual functions using technologies like SR-IOV. Virtual functions appear to the system just like regular devices and can be directly assigned to different virtual machines using standard device pass-through technology. VMs attached to virtual functions require vendor drivers for the NIC being used. The VM will see devices, or NICs, as the same model as the physical device. The NIC configuration is achieved using NIC profiles to assign the virtual function NIC to the VM. More on that later. Once a VM is connected via a NIC profile to the virtual function, all network traffic will bypass the hypervisor, flowing directly between the NIC and the VM. Now let's explore feature 13078, data path offload support for AHV. In virtualized environments, network traffic flowing through a virtual switch, like an Open vSwitch, typically requires processing by the host CPU. This can lead to significant CPU resource consumption, as we've already covered, especially in high-throughput network environments. In these deployments, the CPU manages the entire networking data path. A solution like SR-IOV bypasses the complete Nutanix network stack, but it leaves customers having to choose a trade-off between Nutanix AHV and the features of Flow versus network performance acceleration. With this release, we introduce Network Data Path Offload for AHV. Data Path Offload moves these tasks to specialized hardware known as SmartNICs or DPUs, allowing these DPUs to handle network processing directly in hardware. This includes functions like packet forwarding, filtering, and some advanced capabilities like connection tracking. By the way, connection tracking will actually be offloaded in a future release. Advanced networking features like microsegmentation with Flow network security and overlay networks with Flow virtual networking are provided by Open vSwitch or OVS. OVS has two parts: a kernel fast path, also referred to as the network fast path, and a user space slow path that is invoked when flows do not exist in the kernel for a packet. By offloading these tasks to hardware, we free up those CPU resources on the host and give them to other functions, improving our overall system performance and efficiency. Widely available NICs like the Mellanox CX6 support a special type of virtual function that can be connected to OVS, allowing us to use features like Flow virtual networking, Flow network security, and IPAM. These models enable the network fast path to run on the NIC, while the network slow path still runs in the host user space. To enable this capability, a VM is connected to a VF representer. A VF representer acts as the representative of a virtual function on the physical NIC. The drivers for the physical NIC must be loaded into the guest VM itself. To that VM, the VF representer just looks like a NIC. Now that we've gone through the features SR-IOV and data path offload, let's look and see how we can configure our environments to utilize these features. To configure SR-IOV or data path offload, we introduce the new NIC profile construct to Prism Central. This can be found navigating from the main infrastructure dashboard to hardware and then NICs. A NIC profile defines the desired function for the profile, either SR-IOV or network offload. We then select the hosts that contain eligible NICs and assign NIC ports from the selected host to a profile. Once we have our profiles created, we can then connect our VMs to the profiles. Guest VMs can attach to one or more of the NIC profiles. You must ensure that the correct NIC driver is installed in the guest VM for it to operate properly. On PowerUp, the VM is mapped to one of the physical NICs from the selected profile that has virtual functions available. Scheduler will assign the guest VM to the best host meeting all the criteria. When a VM is associated with a NIC profile and powered on, the packet processing for the associated VM then bypasses the hypervisor stack. Here are some things to know. SR-IOV and data path offload require the compatible NIC drivers to be installed on any VM using this feature. Each capable NIC will support up to 8 virtual functions with this release. You should not enable SR-IOV on VMs that are protected with flow network security policies. This will cause performance degradation as the connection tracking is not currently offloaded. If offload is required for VMs using Flow, use data path offload instead. If a guest VM is a member in a recovery plan within the same Prism Central, the NIC profile is preserved on failover. For other scenarios, you must manually map the VM to the proper profile on failover. Live migration is currently not supported for VMs using SR-IOV or data path offload. Here are some additional things to know. These features are currently qualified and supported on the NX hardware platforms only. Other platforms will be qualified in a later release. The advanced NICs we currently support for SR-IOV and data path offload are the NVIDIA CX6, DX, and LX interfaces. Other interfaces will also be qualified in a later release. A virtual machine must have the correct NIC driver installed to use either of these features. Please check out NVIDIA's support page to locate the proper driver for your OS and the NIC model we're using. The SR-IOV and network offload features require a minimum AOS and Prism Central version of 7.3. The AHV hypervisor version must be 10.3 or higher. Additionally, network offload requires the network controller version 6.0.0. Today, these features are supported on Nutanix NX hardware platforms using the NVIDIA CX6, DX, and LX NIC cards. Planning is available in Nutanix, and these features are available with all licensing tiers. Thank you for watching this session on features 13433 and 13073. Support for SR-IOV and data path offload for AHV.